Hi everyone. Today we're going to talk about threads. Last time we discussed processes, which are programs in execution with a unique memory address space. Each process may have one or more threads, which each represent a single execution context and a separately schedulable task. Each thread has its own unique register state, including its own instruction pointer and stack pointer, and thus represents a virtual core that is executing code sequentially. Thus, we sometimes say that threads provide the illusion of multiple cores executing concurrently. Protection has little to do with threads, since they share an address space and thus share the heap and global variables of a process. Although they each have their own stack, they can still access the memory or stacks of other threads. For example, one thread can pass in the address of a variable on its stack as an argument to creating a new thread, and thus the new thread can modify that variable however it wants. Each process has an isolated memory address space, which allows us to create a protection domain. Threads also use a kernel structure called the thread control block to keep track of the attributes that uniquely characterize them, like their registers and a pointer uh, to their user stack. Now, let's define the POSIX functions related to threads that you can use to create and interact with different threads in a given program. POSIX stands for Portable Operating System Interface, which is basically an interface to define user and system level APIs that ensures software compatibility across Unix like systems. pthread stands for POSIX thread, uh, which are a set of standards specifying how threads should behave on Unix and Unix like systems. These thread syscalls roughly correspond to the syscalls that you used for processes. pthread create will create a new thread in the calling process that runs the function start routine with the argument arg. This function will update the value of the pthread t thread argument to correspond to the ID of the newly created thread. pthread exit terminates the calling thread and is called implicitly when the start routine function terminates, similarly to how the main function of a program or process implicitly calls exit. Yield basically relinquishes the CPU from that thread, and so yield will trigger the scheduler and say, hey, run your scheduling algorithm to see if there's another thread you would rather run than me. However, there is an important difference between yield and join. Join is the equivalent of the wait syscall with processes, but for threads, where if we create a thread and then pass in the thread's ID to pthread join, as you'll see in a later example, the thread who called join will be forced to wait uh, until the thread it joined on terminates.